A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Let us start this class with a story. Do you know a mathematician named Mr. Gauss? There is a story that happened in his childhood. He was brilliant in mathematics even in his childhood. Gauss was of 10-year-old when this story happened. The teacher gave his class a tedious assignment of summing the first 100 integers. The teacher's aim was to keep the class quiet for some time. All the students started from 1 and added each numbers. But Gauss immediately gave the answer. The answer he gave was 5050. The teacher was wondered and asked Gauss how he got the answer. Gauss replied that if we add 1 and 100, we will get 101. Similarly, if we add 2 and 99, then also we will get 101. Adding 3 and 98 will also give 101, and so on. So there are 50 such pairs. Then multiplying 50 and 101 will give the answer, that is 50 into 101, which is 5050.
From this story, we got the method to find the sum of counting numbers. Notice the given triangle is made up of balls. We have to find the total number of balls used in the triangle. Consider each line. On the first row, we can see there is one ball, and on the second row there are 2 balls. Similarly, on 10th row we can see there are 10 balls. So the sum of balls up to 10th row can be written as 1 plus 2 plus 3 plus etc. up to 10. To find this sum, let us add one more triangle to the given triangle as shown in figure. Now we can see that in each row there are 11 balls and there is a total of 10 rows. So the total number of balls that can be written as 11 into 10, that is equal to 110 balls. Now the first triangle has the sum that is half of these 110 balls, that is 1 by 2 into 110, that is equal to 55. So the triangle given has 55 balls.
If we consider this mathematically, the sum of balls in triangle 1 can be written as 1 plus 2 plus 3 plus 4 plus etc. up to 10, and sum of balls in triangle 2 is 10 plus 9 plus 8 plus 7 plus etc. up to 1. Adding these as shown, that will give 1 plus 10 will give 11, again 2 plus 9 will give 11, 3 plus 8 will give 11. So similarly 11 plus 11 plus 11 up to 10 times. Then the sum of balls is 10 into 11, which is 110. Sum of balls in one triangle is half of 110, which is 55. Now by using same method, we can add numbers from 1 to 100, that is 1 plus 2 plus 3 plus 4 plus etc. up to 100, and 100 plus 99 plus 98 plus etc. up to 1. Adding this will give, that is 1 plus 100, which is 101, 2 plus 99, which is 101, etc. up to 100 times. So that will be 100 101s available. The sum of this will be 100 into 101. Here we need half of this, as we need sum of elements from 1 to 100 only. So sum of terms from 1 to 100 is half into 100 into 101, that is half into 10,100, which is 5050.
Starting from 1, sum of any consecutive counting numbers can be found using the same method. That is, the sum of first 25 counting numbers will be the half of the product of 25 and 26. Starting from 1, if we write the consecutive counting numbers, the sum of the same will be the half of the product of last number and the next number of the last number. In the language of algebraic expression, it can be written as 1 plus 2 plus 3 plus etc. up to n is equal to n into n plus 1 divided by 2. We can also find out the sum of even numbers starting from 2. That is, for example, let us find out the sum of even numbers from 2 to 100. Now let us take 2 outside from all these numbers, that is 2, 1 plus 2 plus 3 plus etc. up to 50.
That is 2 times of sum of counting numbers up to 50. Here 1 plus 2 plus 3 plus 4 plus etc. up to 50 can be written as 1 by 2 into 50 into 51. So 2 plus 4 plus 6 plus etc. up to 100 can be finally written as 2 times of half into 50 into 51, which is equal to 50 into 51, where 2 and 1 by 2 will cancel out each other. The answer will be 2550. So by generalizing, it can be written as the sum of even numbers, that is 2, 4, 6, 8 etc. up to 2n is n into n plus 1. Here n is the number of terms. Similarly, let's find the sum of multiples of 3 up to n terms, that is 3 plus 6 plus 9 etc. up to 3n. If we take 3 outside, 3 into 1 plus 2 plus 3 etc. up to n terms, which can be written as 3 into 1 by 2 into n plus 1.
Now let us find the sum of first n odd numbers starting from 1. In the language of algebra, nth term of odd numbers can be written as xn is equal to 2n minus 1.
Consider this as the sequence of odd terms. Here each term can be written as x1 is equal to 2 into 1 minus 1, x2 is equal to 2 into 2 minus 1, x3 is equal to 2 into 3 minus 1 etc. up to xn is equal to 2 into n minus 1. Here sum of these terms can be written as x1 plus x2 plus etc. up to xn, that is 2 into 1 plus 2 into 2 plus 2 into 3 etc. up to 2 into n minus 1 plus 1 plus 1 plus etc. up to n times. Taking 2 outside from the first part, 2 into 1 plus 2 plus 3 plus etc. up to n minus 1 plus 1 plus etc. up to n times, where 1 plus 1 plus etc. up to n times can be written as n. So it is further simplified as 2 into 1 plus 2 plus 3 plus etc. up to n minus n, where 1 plus 2 plus 3 plus etc. up to n can be written as n into n plus 1 by 2. So 2 into n plus 1 divided by 2 minus n, where 2 and 2 will cancel out each other. So that will be equal to n into n plus 1 minus n. Multiplying n through the brackets, we will get n square plus n minus n, where n and n will cancel out each other and answer will be n square.
That is, starting from 1, the sum of first n odd numbers will be the square of number of terms. Now let us consider the sum of terms in an arithmetic progression. We already learned the algebraic form of an arithmetic sequence will be in the form of a n plus b. If we consider the values for n as 1, 2, 3 and 4 etc.
x1 equal to a plus b, x2 equal to 2a plus b, x3 equal to 3a plus b etc. xn is equal to na plus b. Adding all these, we will get x1 plus x2 plus etc. up to xn is equal to a plus 2a plus etc. up to na plus b plus b etc. n times. If we take a outside, a into 1 plus 2 plus etc. up to n plus nb, n times of b will give nb. So again use the formula 1 plus 2 plus 3 etc. up to n can be written as n into n plus 1 by 2. So the final solution will be a into n plus 1 divided by 2 plus nb. So for the arithmetic sequence, if the algebraic expression is xn is equal to an plus b, then the sum of first n terms can be written as, that is x1 plus x2 plus etc. up to xn is equal to a into n plus 1 divided by 2 plus bn. Let's see how can we find out the sum of first 100 terms of the arithmetic sequence 1, 4, 7 etc. The first term here is 1 and common difference is 3. That is, the nth term can be written as xn is equal to 1 plus n minus 1 into 3. If we multiply 3 into the brackets, we will get 1 plus 3n minus 3, that is equal to 3n minus 2. The sum of first 100 terms is, use the formula a into n plus 1 divided by 2 plus bn. Substituting the values where a is 3 and n is 100, that is 3 into 100 plus 1 divided by 2 plus minus 2 into 100. That is equal to 3 into 5050 minus 200, that is 15,150 minus 200, that is equal to 14,950.
Now let us make some changes in the algebraic form to find the sum in more simplified way.
That is, a into n plus 1 divided by 2 plus bn can be written as half into n into a into n plus 1 plus 2b. That is, half into n into an plus b plus a plus b. Here an plus b is the nth term, that is xn, and a plus b is the first term, that is equal to x1. The sum of first n terms of the sequence x1, x2, x3, etc. up to xn of an arithmetic sequence is x1 plus x2 plus etc. up to xn is equal to half into n into xn plus x1. By using this equation, let's find sum of first 100 terms of the sequence 1, 4, 7, etc. again. Here the first term is 1 and common difference is 3. Let's find the 100th term as 1 plus 100 minus 1 into 3. That is 1 plus 99 into 3. That is equal to 1 plus 297, which is equal to 298. Now the sum of first 100 terms is, use the formula half into n into xn plus x1, half into n is 100 into xn is 298 plus x1 is 1. So that is equal to 50 into 299, which is equal to 14,950.
Now let us find the algebraic form.
The algebraic form of the sequence 3, 10, 17, etc. is 3 plus n minus 1 into 7. That is equal to 3 plus 7n minus 7, which is equal to 7n minus 4. The sum of first n terms of the sequence can be written as 7 into n plus 1 divided by 2 minus 4n, which is equal to 7 into n square plus n divided by 2 minus 4n, and 7 into n square plus n divided by 2 minus 4n. It can be further simplified as 7n square plus 7n minus 8n divided by 2. That is equal to 7n square minus n divided by 2. That is half into 7n square minus n.
The algebraic expression 1 by 2 into 7n square minus n defines the sum of terms of this sequence. If we take the value of n as 1, then the first term will be 3. If we take n as 2, we will get the sum of first two terms. Now let us consider the opposite of this. If sum of n terms of an arithmetic sequence is 3n square plus n, then find the sequence.
If n is 1, the first term will be 3 into 1 square plus 1. That is equal to 3 into 1 plus 1, which is equal to 4. The sum of first two terms is 3 into 2 square plus 2, which is equal to 3 into 4 plus 2, that is 12 plus 2, which is equal to 14. The second term is the difference of sum of two terms and first term. That is, second term will be 14 minus 4, which is equal to 10. So the sequence have first term 4 and second term as 10. So the common difference will be equal to 10 minus 4, which is equal to 6. Then the sequence can be written as 4, 10, 16, etc.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.